Chapter 7, Lesson 1, Multiplication Properties of Exponents. So what we're going to be doing today is we're actually going to start multiplying like bases with exponents. So remember, whenever you have a number with an exponent, the big number is called the base, and the top number is called the exponent. So we can only multiply like bases, or ones that have like terms. And so when we multiply them, what we're going to do is we're going to add the exponents. Now, if our bases also have coefficients, those will just get multiplied together. And remember that if a base stands alone, we can give it an exponent of 1. So starting on this first example, I have y to the first times y to the fifth. Those are like bases. So if I have 1y here and 5 here, I have y to the sixth total. Number 2, n to the seventh times n to the second. They're both n's, and that would give me a total of 9. This one, I do have a coefficient here of -7, and there's no other coefficients to combine it with, so I'm just going to put that first. And then I have these bases, x to the second, x to the fourth, becomes x to the sixth. On this one, I have 3 like bases, so x to the first, x to the second, and x to the fourth would be a total of 7. On this one, I have 2 coefficients here, 2 and 8, and there's no symbol in between my parentheses, so I know those are being timesed. And then I have a to the second, a to the first, so 16a to the third. On this one, my only coefficient is 4, and then I have x to the third, y to the fourth. On this one, I have 3 coefficients. I have 1/3, 2, and 6. And so when I take 2 times 6 times 1/3, I get 4. There's no other a's, so I'm just going to leave this as a to the third. And then b to the 1 times b to the third is b to the fourth. This one I have 2 coefficients to multiply, so -20. X to the second, x to the first is x to the third. Y to the first, y to the fourth is y to the fifth. This one, coefficients, 2 times -10 is -20. There's x to the fourth, y to the sixth, z to the third. Okay, the other property we're going to work on today is the distributive property. So when we have a base with an exponent and then to another exponent, we are going to distribute it. So we're going to use the number in the exponent and we're going to multiply by the number that's being distributed. So on this one, I have y to the fifth squared. So what that actually means is y to the fifth times itself. So either way I do it, if I do 2 times 5 or 5 plus 5, I still get y to the 10th. This one is n to the 7th 4 times. So if I add those up, or if I just take 4 times 7, I would get n to the 28th. On this one, first I'm going to distribute x to the 10th, and then I'm going to combine like terms. So now that I'm done distributing and I'm just combining them, it's going to become x to the 13th. On this one, I'm going to give the a 1. The coefficient is on the outside of this parenthesis, so it is not going to get distributed to. So I'm only going to distribute the 3 to what's inside the parenthesis. So it's going to become 3 to the third, a to the third, b to the 12th. However, in number 5 now, my coefficient is inside the parenthesis, so now it is going to get distributed to. So this is going to become -3 to the third, a to the third, and b to the 12th. Same thing on number 6. I'm going to distribute this to everything inside the parenthesis, so it's 4 to the third, x to the 6th, b to the 3rd. On number 11 here, it's a double distribute. So negative 4 to the 3rd, x to the 3rd, y to the 3rd, and then negative 2 to the 3rd, x to the 6th. To combine like terms, I'm going to take negative 4 to the 3rd times negative 2 to the 3rd, which is 512. Then combine my x's, so x to the 9th, and there's no other y's, y to the 3rd. All right, on these ones, I have to express each area of the figure as a monomial, which mono means one, nomial means term. So I'm basically combining these together to make it one term. This is a rectangle, and I know that the formula for the rectangle is length times width. So I'm going to do 6 times 3, which is 18. Combine the a's to be a to the 3rd. Combine the b's to be b to the 6th. The formula for the circle is pi times radius, which is 5x to the 3rd, squared. Distribute here would give me pi times 5 to the 2nd and x to the 3rd. Now in your book, they might combine the pi times 5 squared. So they might have 78.54 x to the 6th. Or they might just have the 5 squared is 25 pi x6. I'm not quite sure which one they'd have in the back. Either one is fine. And there's your assessment.